Okay, we're into our first video for chapter 18, amines. Let's talk about naming amines. It actually turns out naming amines is very similar to naming alcohol. So really the only difference is what the suffix is. For an alcohol, the suffix was all for alcohol. For amines, the suffix is simply amine. Now there are two different ways that primary amines like these can be named. And I'm just going to stick with one method just to avoid any potential confusion. Alright, let's just start off with this guy. Just like with alcohols, if this were an alcohol, we'd say, well, the longest carbon chain is 4 carbons, so butane, lop off the E, stick all on the end, butanol, in this case 1 butanol. The difference here, of course, is that the suffix isn't all, it's amine. So butane, lop off the E, stick amine on the end, because E and A are two vowels, so that's why we have to lop off the E. The NH2 could go on carbon 1 or 2, so therefore, because it's on 1, it would be 1 butanamine. Alright, it's important not to miss out that syllable. Alright, all we're doing is lopping off the E and sticking amine on the end. It's not 1 butamine, it's 1 butanamine. Take 1 butane, lop off the E and stick amine on the end. Alright? Now let's move over here. Alright? It's just like if this were an alcohol. This would be cyclohexanol if it was an alcohol. But it's not an alcohol, it's an amine, so this becomes cyclohexanamine. This comes from cyclohexane. We lop off the E and stick amine on the end. There's no need for any numbers here because there's nothing else on the ring. Cyclohexanamine. All right. When we go down to, let's have a look at this one. We'll come back to this alkene one here in a minute. If those two methyl groups weren't here, then the name would be simply cyclopentanamine. All right. And again, there's a similarity to alcohols here. We saw for cyclic alcohols, we always assumed the OH was on carbon 1 and we numbered everything else relative to it. And it's exactly the same here. So if we assume the amine is on 1, then the methyls must be on 2 and 3. So therefore, the name of this would be 2,3. We've got 2 methyls, so therefore we know it's di. Alright, 2,3-dimethyl. And then just the rest of the name, cyclopentanamine. Boy, trying to write this on this board is not the neatest thing around, but hopefully you can read it. 2,3-dimethyl cyclopentanamine. It's quite a mouthful. All right, let's move on to this last one. All right. Once again, let's just name this as if the double bond were not here. Longest carbon chain is how many carbons, you say? 27? Okay, close. It's 5 carbons. So therefore that would be pentanamine. But the amine's not on carbon 1, it's on 2. So therefore 2-pentanamine. Alright? However, we know this isn't going to work. Alright? Because we have a double bond here as well. Alright? So, how are we going to take this into account? Well, we do it in exactly the same way we did for an alcohol. All right? We want to make sure that we have the number corresponding to where the amine is comes right before the amine, and then the number corresponding to where the double bond starts comes right before that. All right? Okay, let's see. So we know we're going to start off with 5 carbons. All right? And we know the alkene starts on, well, what carbon does it start on? Well, the NH2 has priority, so therefore the alkene starts on 3. So it would be pent3-ene. If this was an alcohol, it would then be 2-ol, but it's not an alcohol, it's an amine. Pent3-ene 2-amine. Pent3-ene 2-amine. All right, that makes sense? I hope so. All right, let's move on to the next slide. Actually, let me just go back a bit. These were all similar in that they're all primary amines, so they're all named in exactly the same way. The only thing that's different between amines and alcohols is that the naming convention for secondary and tertiary amines is a little bit different. So if you've got primary amines down, secondary and tertiary amines are actually easier. Right? Simply put, for a secondary amine like this, we're actually going to start off simple. We're going to start off with a symmetrical amine, or where the groups coming off the nitrogen are all the same. All right. So this one's secondary, and this one is tertiary. And as you'll notice, in each case, the alkyl groups coming off the nitrogen are the same. The alkyl groups coming off the nitrogen are the same. Don't worry about the hydrogen here, but do make sure you understand that each nitrogen in each case has 3 bonds. All right. So whenever we're talking about secondary or tertiary amines, all right, the simple way to name these is to just have the word amine at the end, and then have the alkyl groups named literally as substituents. Okay, so how would we name this then? If we were to name these 2 sets of carbons as substituents, what's a 2-carbon substituent called? Well, it's ethyl, so that would be ethylamine, but there's 2 of them. So therefore, this then becomes diethylamine, and literally that's it. Notice we named the alkyl group as a substituent rather than a carbon chain. The book actually says for primary amines you can do the same thing. Okay, so we could call this 1-butylamine, but I don't want to confuse things any more than absolutely necessary, so let's stick with this convention for primary amines. We have no choice. We have to do it this way for secondary amines because we have more than one alkyl group to talk about. So this one becomes diethylamine. You'll notice there are 3 alkyl groups here that are all the same, so what do you think the prefix will be here? Of course it will be tri. And it wouldn't be triethylamine, it would be tripropylamine. All right. So for an amine that looks somewhat complex, it's really not. The only time it gets potentially more complex is when you have secondary or tertiary amines, usually tertiary amines, where the groups coming off the carbon are not the same. Then we have to figure out, well, there has to be some sort of ranking here, which group comes first, which is the parent chain, so forth, so on and so on and so on. Right? When we name these, we actually go back to our primary amine naming convention, and we just name them as N substituted primary amines. So the main thing with these guys is you just want to remember to use the rule, which of my 3 groups coming off the nitrogen has the higher priority, all right? Because whichever one has the higher priority is going to be the parent chain, okay, or the parent group, if you will. So when you look at the 3 groups coming off the nitrogen, it's pretty easy to see that the cyclohexane is going to be the parent chain. So if we were to name that without these 2 groups there, that would simply be cyclohexanamine, just what we had here. So we know we're going to have cyclohexanamine. Let's put that in here. La-di-da-di-da-di-da, cyclohexanamine. And then to take into account the 2 groups, we just name them as substituents. But because they're coming off the nitrogen, then we need to say N whatever. All right. Now, how do you think we order these? Methyl, ethyl? Well, we just use exactly the same rules we have done before. We just go alphabetically. So that means we start off with the ethyl. We usually have a number locator for this, but because it's on the nitrogen, we just have an N. We treat the N just as a number. So N-ethyl. And then the methyl is also on the same N. We need the locator for it as well. Again, we just treat it as a number. See if I can squeeze this in here. What this really should say is N-ethyl, N-methyl, cyclohexanamine. All right. Does that make sense? You can also say N-ethyl, N-methyl, cyclohexylamine, so using this naming convention here. So it doesn't really matter which one you use. The main thing is you remember which of the 3 carbon groups has the higher priority and thus is the parent. Okay, so when we look at this one right here, let's just look at our three groups: methyl, propyl, and 1, 2, 3, 4, 5, 6 hexyl. So straight away we'll know that hexane is the longest carbon chain, therefore hexanamine or hexylamine, let's go with hexanamine. We know hexanamine is going to be the parent name. M comes before P, so therefore the name becomes N-methyl, N-propyl. And the only other thing to think about here is on the 6 carbons of the chain, where is the nitrogen? It's on carbon number 1. So we know therefore it's N-methyl, N-propyl, 1-hexylamine. So therefore N-methyl, again we just treat the N's as numbers. N-methyl, N-propyl, 1-hexanamine. Alright, does that make sense? Good. I'm going to do this slightly out of order. I'm actually going to start off with this. This is something that, as far as its common name goes, some of you may have heard before. It's something called putrescine. Putrescine is derived from the word putrescent, in other words, to smell really, really bad. This has the smell of rotting fish, rotting flesh, rotting things. Basically, it doesn't smell very nice. Most really, really nasty smelling compounds are amines, or in this case, diamines. And in terms of naming this, we would name it exactly the same way as we would name a diol. All right. So we're going to start off with the longest carbon chain, which in this case is 4 carbons. So if this was an alcohol or a diol, it would be butane 1,4-diol. So it's going to be butane 1,4, except it's not going to be diol, it's going to be diamine. And just so we're sure, remember why we don't lop the E off butane? Because the suffix starts with a D. All right, let's see what else. Oh, the other thing we have to talk about here are, let's actually get this guy out of the way here first. We've seen so far amines that have 3 bonds to the nitrogen. In fact, that's usually all we've ever seen. We have seen, though, what happens to a nitrogen when it gets a 4th bond. It stops being an amine and it becomes an ammonium, a positively charged nitrogen with a formal charge of +1. So we need to know how to actually name these then, all right? And the thing to remember is that this is no longer an amine, it's an ammonium. As far as the rest of the name goes, it's exactly the same. So we can name it kind of like this guy. This is tripropyl. This is not tripropyl, this is tetrapropyl. Tetra because there are 4 of them. Yep. Tetrapropyl. And as I said, this is no longer an amine. By the fact we have a positively charged nitrogen, it's now an ammonium. Well, crap, that's supposed to be 2 M's. That looks kind of weird, doesn't it? Let me try that again. My English writing skills should be a little bit better, given my age. Tetrapropyl ammonium. And then the only thing that we're missing here is the fact that because the nitrogen's got a plus charge, it has a negatively charged counterion, and the name of Br-, of course, is bromide. So whenever you see a positively charged nitrogen with 4 groups on there, it's an ammonium chloride or bromide. Tetrapropyl ammonium bromide. All right, let's talk about these last 2. These 2 are very similar. They are aromatic amines. In other words, the nitrogen is coming off a benzene ring. Now, does anybody remember from last semester what the name of an NH2 coming off a benzene ring is? Because that's going to be the name of this guy here. Well, that name is very simply aniline. All right. So how would we name this then? we can actually use the naming rules that we've already seen, because the only thing we need to do is to add on the ethyl and methyl groups. We already know the ethyl comes first because it's alphabetically before methyl. We also know the ethyl is on the N, so therefore that means N-ethyl. We know we can treat the N's like numbers because we've seen that before, so we're just separating by hyphens here. N-ethyl, N-methyl, and then what comes at the end? Well, what comes at the end is the name of the normal amine, which in this case is aniline. So what you're going to find is that the vast majority of aromatic amines are going to be derivatives of aniline. Alright? And the last thing we're going to talk about here, this is something that you guys just need to know, and if there aren't already, there are going to be soon. There are going to be PowerPoint slides of these guys and their corresponding names upon WebCT for you to take a look at. Heterocyclic amines. Now, heterocyclic has nothing to do with their sexual orientation. Heterocyclic just means that the heteroatom, in this case the nitrogen, is inside the ring. So it means cyclic but with a heteroatom already in there, right? And there are 8 different heterocyclic amines that you guys need to know the names of and the structures of. The best way to learn these is just to draw them out until you know them. You can use, like I said, your PowerPoint flashcards to help you remember them. Because the one thing I can guarantee is that the names do not tell you. Quinoline is the old style name for this guy. Imidazole is the old style name for this. Piperidine and pyrimidine and so on. You are not going to, well, you can clearly see these are not functions of an IUPAC naming system. These are common names. So you need to make sure you know them. The only thing I am going to go through here is about naming these when they have substituents. And the main thing that I want to cover is how you number each of the atoms in these rings. All right, let's start with imidazole here. The thing that's always a constant here is you always start counting from the nitrogen down at the bottom of the ring. So I always draw my heterocyclic amines out with one of the nitrogens down at the bottom. That's going to be atom number 1. And then you just go around counterclockwise and name the atoms, or sorry, number the atoms as you go around. Alright, so imidazole 1, 2, 3, 4, 5, piperidine 1, 2, 3, 4, 5, 6, pyrimidine 1, 2, 3, 4, 5, 5, 6. Let me just write those on here. 1, 2, 3, 4, 5, and 6. The only ones that are a little bit different are those that are comprised of 2 benzene rings fused together. And there's only 2 of them, quinoline is 1. Let me just go through this. It's 1, 2, 3, 4, and after 4 we have to make sure we understand that there is a jump. 5, 6, 7, 8. So on quinoline, although there are 10 atoms in the rings, there are only 8 that are numbered. Versus all the others that have every single atom numbered. Now, I don't know if you guys can figure out why that's the case, but let me give you a hint. All these positions are places where you can stick an extra substituent, because you have a hydrogen on each of these atoms and there's a pair of electrons on the nitrogen here. This carbon and this carbon both have 4 bonds to carbon. There is no place anywhere else for us to make bonds here unless we'd like to talk about forming Texas carbons. Hence, because of that, these don't come into the naming convention because they can't be places where things can be located. So if you see on a quiz something like provide the structure for 5-methoxyquinoline, then first off, I'm hoping what you'd recognize is, well, first thing, it's quinoline, so I know I'm going to have my 2 rings All right. Well, you know what, bollocks to that. I'll just write it on the structure that we have. 5-methoxyquinoline, all that means is I have a methoxy group coming off carbon 5 in quinoline. So I draw out quinoline, all right, and then I remember, okay, well, I know what a methoxy group is, don't I? Well, of course I do. And it's coming off carbon 5. And a methoxy group, of course, is an OCH3. So whenever you are naming heterocyclic amines like this, all you gotta know is exactly what atom is where and stick the group where the number says. All right. And always remember, count counterclockwise, not clockwise. All right. And that is heterocyclic amines. Just make sure that you look these up and that you know these structures, because once again, the names won't help you out. All right. Okay. Thanks.